Welcome back. I am Anshu and you are watching Bottleneck. This is the Agenti AI Cookbook series where we learn and implement design patterns for AI applications using hands-on examples. Alright, a quick recap. In our previous video, we discussed about our customer support agent use case, which is an example for dynamic routing in Agentic AI. We had discussed in detail what the use case is about. And we also discussed the different routing strategies. We implemented ML based routing, LLM based routing, embedding based, and rule based routing. If you have missed on my previous video, I will be sharing link in the description. Alright, now in this video, we will continue with our development for the nodes and the graph. Okay, so for the nodes, let's create the prompts. Now we know that we have three different agents: billing, technical or the tech support, and the general. All of them have same behavior. The difference will be in terms of message. This is the simulation, not a real-time production ready solution. So let's create a generic method: dev create agent chain. All right, this takes a prompt which is a type of string, and it will return a runnable. Let's return chat prompt template dot from template, and we pass the prompt message here. Prompt message, we pipe it with LLM and with string output parser. All right, so this is a generic method. We will use it to create our chain. So first chain is the billing agent. So let's create the billing agent. All right, so what billing agent is, or what it will require, let's give it create agent chain. So you are a billing support agent. Okay, now answer in one line, max 10 words. We are putting these restrictions for the demo purpose. In real-time scenario, you can have more generic or detailed prompt. All right, so we pass the query and this creates our billing agent. Similarly, we need tech support agent. So we will have a tech chain or tech chain. Okay, so let's name it as billing chain. We will create agent as a node. Okay, tech chain and create agent chain. Here again we need to provide a message: you are a technical support agent, you are a technical support agent, and answer in one line in 10 words, max 10 words. Okay, so we can just copy paste whatever we have here. And finally, something similar we will have for our FAQ or general agent. So let's name it as FAQ chain. So let's name it FAQ chain, and you are a general FAQ support agent. All right, support agent, and it has to also answer in one line. So this way we create the chains that we require for our graph. All right, now let's create the graph. So what we need is a class or a shared schema that is going to be an agent state. Okay, and this agent state will require a typed dict which we need to import. Okay, let's import the type dict. Let's go up, and all right, so from typing extension import typed dict. All right, now let's complete the class that we have. So this class will have query, okay, which will be a string, that is a user query that we know, okay. Then we have route, okay, again this is a string, and next we have a response. All right, so this is also a string. Now let's create the nodes. As we know that graph is required and we need a node for the graph. All right, so let's initialize the graph. Okay, so we need a graph as well. Let's go up and import the graph from lang graph dot graph import state graph. All right, let's implement the graph. So we have a graph as state graph, and we feed in the shared schema agent state. All right, so we have the agent state as the schema. Now we need the nodes, so we need to add multiple nodes. So what all nodes that we need to have? So first is the billing node, then tech node, and the FAQ node. So we need to create each of them one by one. So let's create the nodes first. So we have a billing node. Okay, dev billing node. It is going to have a state as agent state. Okay, and it is going to return a partial dictionary. So let's return. All right, first let's define what exactly it is. It's a good habit to add a doc string for readability. So this is a billing agent, a billing node. So what it does, it invokes the billing chain and returns the response. Invokes the billing chain and returns the response. Okay, so return. You can add a better doc string for your readability, but as of now this is good enough. So we add a response as we have billing chain dot invoke, and it requires a dictionary. It will need a query. Okay, this query will come from state query. Okay, similarly we have tech node. Okay, so what we can do is let's copy it out so we can do it faster. Let's rename it as tech node, and the chain will be tech chain. Okay, and finally we have the FAQ node. Let's name it as FAQ node. Okay, and we will have the FAQ chain here. All right, so till now we have implemented the nodes. Now let's add these values to the graph. So the graph is supposed to start with a entry point as router. All right, so we need to have a router in place. So what is our router here? Our router are four different strategies that we have designed, and we need to add those values as part of the node. All right, so let's first add our first router. Let's start with the rule based. Okay, so graph dot add node. Okay, and we will add in the router, and it will be rule based router. Okay, now we need to have the other values which we added as the node. So let's add each of them one by one. Graph dot add node. we have billing. So make it a billing node. Sorry, billing node. Okay. And we have graph dot add node. Now we have tech support. So we can say technical. We need to be very careful with the keys that we are putting in, because again there will be a lot of pattern match that will happen inside the graph. FAQ node. Oh, this is technical, so this is going to be tech node. Okay. And finally graph dot add node. Okay, so this will be general, and this is going to be FAQ node. All right, now we have added these three nodes, but we need to add a condition. So whenever a router meets a value which is billing, it should go to billing, and when it goes to technical, it should go to a tech node, and finally if there is something other than the technical or billing which is general, then it should go to general node. So let's add a conditional node. So graph dot add, we have conditional edge. Conditional edge takes three parameters. First is the entry point, that is router. Second would be the logic, so we will write a lambda here for this because it's a simple logic that we are going to see. So it's going to have a state, the value is state, and we mark it as done if state dot get response, else state route. All right, so now if there is some response, it will get it done, the value will be done. If not, then it will return the route. Now the third component is the path. So if it returns billing, it should go to billing node. Okay, now if it returns technical, it should go to technical node. Okay, so we need to be very careful with the keywords. It is supposed to be a dictionary. Okay, it cannot be a tuple of values, it's a dictionary. So the third parameter is the path, and that is a dictionary. All right, so we have general, which is again general. All right, so in rule based, as we have seen, we are returning these three values: billing, technical, and general. So router will throw three values. If not, it will throw a done. Okay, so when we encounter done, then it means it is end of the life. Okay, or end of the execution. And so we will import end from the graph itself. Okay, all right, so now we have the condition set here. All right, so router is the entry point. We will set the graph entry point, graph dot set entry point as router. Okay, now we have the entry point set as router. Once the graph starts with router and the logic is filled in, it will throw a response. Either it is going to be done or one of the routes. If it is done, then it will go to end. If not, then it will go to either of these paths. And that brings us to the end of the part 2 of our customer support agent implementation. Till now, we have implemented multiple routing strategies, from rule based and machine learning approach to LLM driven and embedding based routing. These strategies help the system intelligently classify user queries and direct them to the right specialized agent. In the next part, we will take this further and we will implement the land graph. We will complete the workflow by defining and constructing the graph for all the different strategies, and we will see it a fully functional agent end to end. So stay tuned. If you found this helpful, don't forget to like, share, and subscribe for more practical insights into AI architecture and design pattern. All right, see you in the next video. Thank you.